Aloha everybody, my name is Nick Joseph, and on behalf of the rest of the team at Data and Urban Development, we're thrilled that you could join us for our final Codeup project, Region of Boom, where we take a look at all the major US markets and try and see if we can predict which ones are on the cusp of a real economic boom. But let's face it, none of this is fun, none of this is interesting unless you know the people behind it. So let me go ahead and introduce you to our team. We have Alec Hartman, Daniel Guerrero, Noah Melngailis, and me, Nick Joseph. What we're going to do today is actually walk you through the story of the data. A little bit, broad strokes of what happened, a little bit about the tools we used, and then we'll dive into the nitty-gritty of the specific problems we faced and how we used everything we learned at Codeup to get the job done. Okay, so how does all this work? Well, first we had to pull the data, which is publicly available, from the US Census Bureau. Then we set out to see if we could predict which cities were about to see a spike of investment in both infrastructure and new construction. And the end result was amazing. We developed a machine learning classification type model that's 91% accurate against the test data. So what that basically means is, like, if you took this thing and deployed it into the real world as it is, you'd be right 91% of the time. Not too shabby, especially coming from nothing. So to frame everything, we have to understand we had a client, a particular audience in mind, and this was TestFit.io. They are a pre-construction software company whose specific interest, at least for this project, was multifamily housing, apartments. They're looking for apartments. But because of the nature of their business, they have to get in before the boom actually hits, or else they lose out. So what we did was we tried to figure out a way to answer the question, where are the sleeping giants and when are they waking up? So let's take San Antonio for instance. The question would be, should TestFit enter the San Antonio market in 2021 and expect any kind of reasonable return by 2023? Well, of course. Well, I'm not going to spoil the ending there. But what I am going to do is pass the buck over to Noah because he's going to explain to you the tools we used and how we use them. Take it away, Noah.
Thank you, Nick. Our project was built in Python with Jupyter notebooks running .py scripts and using GitHub for collaboration. First, we web scraped files on the Department of Commerce website to acquire the data. We took that data into a Pandas data frame, cleaned, organized, and shaped it into a usable format. From there, we used SciPy to perform statistical tests and visualization libraries in Python to explore the data. For modeling, we used the sklearn library to scale, cluster, and then build predictive models. Finally, we created deliverables in Tableau and Google Slides to present our data. Our data reported high-density multifamily housing for 390 metropolitan areas from 1997 to 2019. The dataset had market size, number of buildings, and number of units built for multifamily housing. From this data, we engineered features showing market performance and growth. How do we create a model? Let's get back to our initial example. Our model compares the San Antonio 2021 market to historical data. And from that, we want to make a prediction. But we can't, because we have not defined the different types of markets. We need to label the data to perform supervised machine learning so we can use the actual data to perform the predictions to determine if the market is profitable to enter or not. But before we can do that, we need to answer some questions. How do you define a hot market? And how do you measure it? And that will take us to clustering. Take it away, Alec.
Thanks, Noah. Okay, folks, so now that we have some context for our project, the data that we used, and the necessity of labels for supervised machine learning, let's talk about how we arrived at our labels, clustering. Clustering is a method that data scientists use in order to determine groups of alike observations in their data based on their proximity using specific features. As you can see on your screen, we have 6 clusters denoted by their unique color. The specific features by which we clustered these observations are average units per building and the evolution index. We deliberately chose these features as they relate directly to our stakeholders' research question: how many high-density multifamily structures are being built in the United States every day? As our measure of density, we chose average units per building. Let's talk about the x-axis. As we move to the left, we will observe markets where there are fewer units per structure or lower density. As we move to the right, we will observe markets that are considered higher density or more units per structure. Okay, so now that we've oriented ourselves with our x-axis, let's talk about the y, the evolution index. The evolution index is a market's relative performance in relation to the greater US multifamily housing market. Let's talk about how this works. As we move down our y-axis, we will observe markets that are underperforming in relation to the greater US market. And as we move up the y-axis, we will observe markets that are outpacing or outperforming the greater US market. So let's talk about how these clusters intersect our axes. We defined top performing markets as those that will be considered high density and outperforming the greater US market, those located towards the top and right of our simple representation here. The markets that will be considered lower performing are just the opposite of that, lower density and underperforming in relation to the greater US market. So now that we've oriented ourselves with what these clusters represent, let's talk about how we use them. It's important to remember now that each observation is a specific market in a moment in time. The blue dot that you're seeing on your screen is labeled as San Antonio in 2012. Knowing this, we can plot the trajectory of each market as it moves between clusters, profitable and unprofitable alike. At this point, it's important to step into our stakeholders' shoes. Real estate is a long-term game, and we want our stakeholder to be established in a market that is booming 2 years prior to that predicted boom. We identified markets that were underperforming at one point, and then 2 years later, were outpacing the greater US multifamily housing market. As you can see on your screen, San Antonio was just this market in 2012 and then in 2014. We applied this logic to the rest of our observations in our data set and created labels in order to identify emerging markets. Let's take a look at the real thing. What you're seeing on your screen now is the actual representation of the clusters that we created in our data. We are using the same axes here, average units per building on the X and the evolution index on the Y. You may notice that these axes are now scaled. However, the principles that we established with our simple representation of our clusters still apply. Our top performing markets are going to be up and to the right of our graph, and our lower performing markets will be down and to the bottom left. Each cluster here is again denoted by a specific color. The X's that you're seeing on your screen are the center of each respective cluster. And the red line bisecting this plot is what we labeled the evolution index threshold. This identifies markets that are performing on pace with the greater US multifamily housing market. So now that we have our labeling convention, let's put them to use. Daniel, tell the people what they've won.
Thank you, Alec. Now let's recap what we've done so far. Alec and Noah did a phenomenal job of giving you a brief overview of how modeling works. And now that Alec has given you an overview of how we actually accomplish our labels, we're ready to dive deeper into the modeling. So how did our model actually work? We looked at trends and data from 2018 and 2019 to predict what the data would look like by 2021. We then used a classification model called K-nearest neighbors, and the way the model works is that it takes our predictions, so for example, San Antonio 2021, and it compares it to all the historical data, and it's actually looking at the relative distance or the difference in value between our prediction and the historical data. In this case, San Antonio is actually closest to the green dots than the red dots, so the model will label it as green. In reality, our model is a little bit more complex. It looks at the market size, it looks at the number of buildings, the number of apartments per building, the overall performance of that market, and the cluster that that city belongs to. And so it actually combines all of these data points together, and it will compare them and their value to the historical data, and look at, again, the relative distance. And in this case, the model actually predicts that San Antonio will be an emerging market by 2023. So we recommend our stakeholder to enter this market by 2021. Now, how often is the model actually right? We actually found that by using multifamily housing data, historical data, we're able to get a 91% accuracy. Now, 91% accuracy is truly amazing, and the reason why we couldn't be happier with this result is because this result is actually on test data. So it's data that the model has never seen before or was trained on. And this is something that traditionally is very hard to accomplish. So out of 130 unique cities, how many does the model recommend testbed enters in 2021? We actually identified 72 cities that we recommend testbed enters. You can see them on the map here. However, 72 cities can be a lot, so we further subcategorized these cities into 4 groups for prioritization. Our first group is the cities that have a high return on investment. What we mean with this is these are cities that by 2021 they'll be underperforming the market. However, by 2023 we expect that they will be overperforming the market. In fact, we expect these cities will grow by about $330 million on average over the next 2 years. Next, we have our medium markets. These are markets or cities that are performing just about the same as the overall market. However, again, by 2023, we expect that these cities will be outperforming the market. We expect these cities on average to grow by about $270 million over the next 2 years. Then we have our stable high cities. These are cities that are already outpacing the rest of the market, but we predict that they will continue to outpace the market for the next 2 years. In fact, we expect many of these cities to continue to grow by about $100 million over the next 2 years. And then lastly, we have the cities that we don't recommend our stakeholder enters. The reason for this is that these are cities we actually expect will decrease in value over the next 2 years. Some of these cities will decrease in value by about $330 million in fact, and so we would want to avoid those. So let's just go over what we discussed in this project overall. Our objective was to create a predictive model that could identify emerging markets so we could help our stakeholder, TestFit, prioritize what markets to invest in 2021. Our findings was that we could use multifamily housing historical data to actually create a model that is 91% accurate. Out of 130 cities, we identified 72 markets that would be profitable for TestFit to enter in 2021. And we further identified 9 markets or cities that would offer the greatest return on investment, as we believe these cities will grow by about $330 million by 2023. Some further improvements that we would recommend for the project had we had more time was to bring census population data. Given that we're using multifamily housing data to make predictions, if we could also understand how population trends are changing and which cities are growing or getting smaller, we could further enhance the accuracy of our project. And with that, we would like to thank you for your attention. We would also like to thank TestFit for the opportunity to work on this project. We had a phenomenal time, and the Codeup staff and leadership for their ongoing support throughout this project. If you want to learn more about the project, we welcome you to visit the Codeup Alum website, where you can find more projects that my teammates and I have worked on. Additionally, if you want to go deeper into this project, we've linked the GitHub report, where you can find a much more in-depth analysis of all the statistical analysis, modeling, and evaluations that we've done. Thank you.